the turtles heading for the ball and falling off the log. They make the water splash and feeling no backlash, they climb the happy
Hi, pre-calculus. Thought we'd begin this video with an old Neil Young song called Deep Forbidden Lake. Anyway, here's a quick video about expanding a logarithm. All right, so the kinds of properties we deal with logarithms, one of the major properties is how to expand a logarithm, or we use those properties to help us expand. All right, so when you're asked to expand a logarithm, you're asked to rewrite a certain logarithmic expression into however many logs you could possibly write that expression in. All right, so we use these two key properties. All right, first of all, log base b of x times y. All right, so if the argument is a product, we can rewrite this as log base b of x plus log base b of y, regardless of the base. It could be a natural log problem, log base 7, log base 10, whatever. You can use this property. All right, so if the argument itself is a product, you can rewrite the logarithm as the sum of two separate logs. All right. If the argument itself is a quotient, it's x divided by y, then we can rewrite the logarithm with subtraction as two separate logs. All right, so log base b of x minus log base b of y. All right, so multiplication in the argument can be broken up into the sum of two logs. Division in the argument can be broken up into the difference of two logs. All right. So we're going to apply those two properties for a couple of examples. All right. So first of all, let's do an example of the product here. All right. So if you had a problem like this, log base 2 of 8 times 32, that was your product. All right. Now, theoretically, you could figure out what 8 times 32 is. 2 to the third, 2 to the fifth, so it becomes 2 to the eighth. You could do it that way. All right. But I'm just showing you another way you could handle it. All right, we can break this up as log base 2 of 8 plus, because it's multiplication, log base 2 of 32. This logarithm you should know is 3. This logarithm you should know is 5. 3 plus 5 equals 8. That's our answer. All right? That is one way we could apply the expanding rule when the argument is a product. Now, this is not to be confused with if the problem was written as a product itself. All right, so if it wasn't log of 8 times 32, if it was log base 2 of 8 times log base 2 of 32, all right, maybe they were in parentheses, who knows, doesn't really make a difference. All right, this is where folks kind of get a little messed up, okay? We are not in this situation anymore. All right, we can't apply this rule because it's not the argument itself that's being multiplied. It's just two separate logarithms that are being multiplied. All right, so I hope you guys see the difference. It's not just the argument was 8 times 32 originally, right? Now it's just one logarithm times another full logarithm. So for this problem, we would just do them separately. We would evaluate this, 3 times 5, and we get 15. That's our answer. There's no other way to handle that. All right, you can't apply the property that we just applied to the previous problem. So it's important to know mistakes that folks have made in the past so you guys don't do them yourself. All right. Another example, let's do one where we use the subtraction property. Right? Log base b of x over y can be expanded as log base b of x minus log base b of y. So if you had a problem like, I don't know, log base 3 of, say, let's do something basic like 27 over 9. Even though, again, you might do 27 divided by 9 and get 3, and then log base 3 of 3 is 1. That's the obvious way to do the problem. But I just want to show you guys how to apply this rule. So we would get log base 3 of 27 minus log base 3 of 9. All right? Log base 3 of 27 is 3. Log base 3 of 9 is 2. 3 minus 2 equals 1. That's our answer. All right, so that's how to apply the rule of when the argument is being divided. All right. Now, you can probably guess what I'm going to show you next. A mistake some people make would be if you have the problem log base 3 of 27 divided by log base 3 of 9. This, we cannot apply this rule, all right? We don't have division only in the argument. We have a log divided by another log. So this one we would have to do just by evaluating the top and the bottom separately, and the answer is just 3/2, okay? So there's no other way to do that problem. All right? Let's do a couple of harder ones where we incorporate some variables. Usually when there are variables involved, that's where some people have some difficulty. All right? So we will do, actually, let's kind of incorporate the problems that we started class with today, and let's just call it log base. It doesn't really matter the base. We can call it base 5, say. We can still apply the property regardless. The base really doesn't matter. 27xy squared. This problem, you would not be asked to evaluate. You would be asked to expand and simplify, okay? Because we can't evaluate an expression that has variables in it unless we know the value of those variables, all right? So for this problem, and any problem you're asked to expand, all right, this is important, okay? Your first step should really be to rewrite the argument without radicals and totally simplified. You want every factor as some expression to a power, not the radical, all right? So I'm going to rewrite this as log base 5 of, first of all, probably want to do this kind of carefully. The cube root means the 1/3 power, right? Now I'm going to raise each of those three expressions to the 1/3. This is why we study exponents before we get into logarithms, because rules of exponents are very important for rules of logs. Right? So we have 27 to the 1/3, x to the 1/3, y to the 2/3. I haven't done anything with logarithms yet, right? I'm just simplifying the exponential expression. And this becomes log base 5, 27 to the 1/3 power, kind of an easier one, right? 1/3 power means the cube root. So this is just 3, x to the 1/3, y to the 2/3. That's where we want to be, okay? Once we're there, now we want to apply the property that I just showed you, all right? We don't want to apply that until we get here, till we have the argument written as the product of all the different factors, each one raised to an individual power, all right? We don't want to use the property yet, or not even yet here or here. We want to make sure everything is simplified first. Now we'll split this up, all right? So now I'm going to rewrite this as the sum of 3 different logarithms, all right? Every factor in the argument gets its own log, even the coefficient. So we have log base 5 of 3 plus log base 5 of x to the 1/3 plus log base 5 of y to the 2/3. All right? Now, there's another property of logs that I'll go over in class that discusses what we can do about these exponents here. But for now, for the purpose of this video, my hope is that you would at least get to that point. All right, just to apply that single property of how to expand a logarithm. All right? So I've simplified the argument. This is a harder problem, obviously, than the previous one we did. And now I've written this as a sum of 3 different logarithms, 1 for each of the factors of the argument. Now, if log base 5 of 3, if that could be evaluated, without a calculator, then you would have to do it. So if it was like log base 5 of 5, you would replace that whole logarithm with 1, right? But log base 5 of 3 is not a rational number. What power of 5 gives you 3? It's not a clean, friendly answer, so we can leave that. All right? One more example. We'll do one now where we incorporate the subtraction property. All right. So let's see. Log base, let's use a base of 9 in this case. Why not? Of the square root of x over 9y to the 6th. All right. Just as before, when we are expanding this, we first want to clean up the argument itself, right, before we apply that property. So we have, you don't need to show every little nitpicky step, but I'm just showing you in this video. This is really all to the 1/2 power, the square root. So we now have log base 9 of x to the 1/2 divided by 9 to the 1/2. Don't forget to raise that value to the 1/2. And then y to the 6th to the 1/2 is y to the 3rd. All right? Now 9 to the 1/2, square root of 9 is just 3, right? So we should we should definitely simplify that here. Simplify all you can before you apply the log property. All right? That's a really good rule of thumb. All right, now that we're here, now we can apply the property or properties of logs. All right, we have the log of a quotient, so we're going to rewrite this as subtraction. Log of x to the 1/2 minus log of this, base 9, right? Base 9. Okay? Now, that's not going to be the answer yet, but that is definitely the first step. We have the log of a quotient, so we'll have log of the numerator minus log of the denominator. Now, if the denominator itself has more than one factor in the argument, we have to keep expanding that, all right? So there's going to be 3 logs in the answer, but this is where we are right now, all right? Now we have log base 9 of x to the 1/2 minus, because we're subtracting a quantity, kind of like that last problem on the most recent assessment, right? You had to subtract those exponents, and the denominator's exponent was a binomial. So you have to distribute the negative sign, right? Same thing you have to do here. We have to distribute. This is a sum of 2 logarithms, right? We have to apply that previous property. Log xy is log x plus log y. So this here is a sum. We have log base 9 of 3 plus log base 9 of y to the 3rd. And because we have to subtract a sum, we have to make sure we distribute the negative to both logarithms, all right? So we now have log base 9 of x to the 1/2 minus log base 9 of 3, which we can evaluate in just a second, and then minus log base 9 y to the 3rd. All right, you have to remember that if, this is not going to happen in every problem, but if the denominator has more than one factor, you have a logarithm that's being subtracted, and you can expand that logarithm further, you have to remember to distribute the negative to any logarithm that's part of that sum. That's why we have minus and then minus again. All right, log base 9 of 3. What power of 9 gives you 3? You can write that out and solve that if you want. 9 to the k equals 3 and whatnot. But you might remember the 9 to the 1/2 would equal 3, right? The square root of 9 is 3. So that'll get replaced with 1 minus 1/2, right? So our final answer, I'll write it up here, would be written as log base 9 of x to the 1/2 minus 1/2. Well, let me write this logarithm next. Minus log base 9 of y to the 3rd minus 1/2. Right? That's your final answer. And again, as you remember from last year probably, there is something we can do with those exponents at the very end, but this problem is kind of hard enough as it is. I didn't want to go too far. My only goal for this video was to get you guys to understand how to apply the rule of if the argument is a product, how we can expand it, and if the argument is a quotient, how we can expand it. This problem is a little harder because of the simplifying process that we had to do. All right? So hopefully this is a good way to start. The problems won't get too much harder than this in the logs unit. So again, if it's something that you really struggled with last year and you understand this, you're on your way to getting it this time around. All right? Have a good day.